Hello friends, in this video I'm going to talk briefly about trapezoidal rule. A trapezoidal rule is an approximation to a definite integral. Okay, so let's begin. Let us say we want to integrate a function f of x in the limit from a to b. We know integration in the sense finding the area under the curve. So first let me draw the function f of x in the xy plane. Okay, let's say this is the x-axis and this is the y-axis. And let me draw the function f of x. Okay, so this is the function f of x. Okay, and we can see here we want to integrate this function fx from limit a to b. So let us mark these points, point A and B in the x-axis. So let's say here the value is A and here is B. And I'm going to draw these vertical lines. Okay. And another one from here. Okay. So now we want to integrate this function, right? Fx in the limit from A to B. That means we want to calculate or integrate this area here, right? Area enclosed by this in this curve, area under this curve from A to B. We want to calculate, integrate this area. Now what I'm going to do is I'm going to draw a line from here to here, right? So this line, it gives a trapezium or trapezoid, right? So this is a trapezoid. So in trapezoidal rule, what it says is this integration is approximately equal to area of the trapezium, right? So this trapezium, area of this trapezium is considered to be the area under this curve. Okay. So okay. So the area of the trapezium we can write. So let us say the area of this trapezium is A. So I can write A equals to half into we know half into the length of this side and sum of the length of this side and this side, right? So I can write, now what is the length of this side? This side, what is this length? Now we know this is a function f of x. If we put a in this function, we get this height, which is fa. So that length is fa. So let's put that here. Plus, now length of this one is fb. Because if we put b in this function, we get the y value, right? Right? Because y equals fx. Right? If you put a into this function, so you get fa here, the y value of fa, and similarly fb. So here this is fb multiplied with the perpendicular height, the height, this height from here to here, no? So we want to this height, perpendicular height from to these two lengths. So this is b minus a. That height can be calculated by b minus a. So that is the area of this trapezium. So the trapezoidal rule says this integration, so the area under this curve is approximately equal to the area of this trapezium. So now I can write area equals half into FA plus FB into B minus A. So now we know what is this area. This area then approximately equal to the integration I, right? So that is the trapezoidal rule. I hope it is clear. Now let's do one example. Okay, let's do an example from trapezoidal rule. Okay, let's say we want to integrate this function square root of x in the limits 1 to 9. Okay, so we want to do this integration. Okay, so first let's consider the graph of this function. So if we plot this graph, we will get something like this. So this is the graph of square root of x. So in this function, we want to integrate from 1 to 9. So here's the 1. Okay. And 9. Okay, so we want to integrate this area. Okay, so first let's integrate using our normal integration. Yeah. Okay, so this is equals to integration limit 1 to 9 square root of x. I can write x to the power half dx. Okay, so let's integrate this. This when integrating this gives x to the power 3 over 2 divided by 3 over 2 limits from 9 1. Here the limit 9 and here the limit is 1. Okay, so now let's put this values here. So this is equals to I can write this 2 over 3 into so here x, that is 9 to the power 3 over 2 minus 1 to the power 3 over 2. Okay, good. So let's simplify this. 2 divided by 3. So 9 to power 3 over 2. So here we have half into 3 in the power component. So taking square root, half means taking the square root. Square root of 9 is 3 and then cube 27. 27 here minus any power of 1 is 1. We know that 27 minus 1. So let's simplify this. We get 2 into 3 multiplied by 27 minus 1 is 26. So this gives 52 divided by 3. So 52 divided by 3 is 1. So remaining 2 there. So 17.333 dot dot dot. So we can take this roughly 17.3. Okay. Okay, now let's integrate this using the trapezoidal rule. Okay. Now let's find this using the trapezoidal rule. So trapezoidal rule says it is equals to this integration I equals to half into f 1 plus f 9 into 9 minus 1, right? Remember the trapezoidal rule, we got half into FA plus FB into B minus 1. So here A equals 1 and B equals 9. So we get F1 plus F9 into 9 minus 1. So let's simplify this. We get half into, so the function value at 1 is 1 plus function value at 9 is 3 multiplied by 9 minus 1 is 8. So let's simplify this further. 1 half, 1 plus 3 is 4, 4 into 8. So we get 4 divided by 2 is 2, 2 into 8, 16. So using the trapezoidal rule, we got 16, but the actual value is 17.3. Can you tell me why we get different values? Now actual value is 17.3, but we got 16 here. So there is something like 1.333 different error, right? There's a difference between these two values. So what is the difference? Can you tell me why? I'll think. Now that difference is because we use trapezoidal rule. So we using the trapezoidal rule, we found this area, right? Area of this trapezium, right? Now by calculating this area of trapezium, we don't take this area into account. So now this area would be 1.333. So that is the difference. That is the reason for this difference in these two values, right? Okay, so I hope trapezoidal rule is clear for you, and I hope to see you all again in another video about composite trapezoidal rule, how we can modify this trapezoidal rule so that we can minimize the error. So we can see if there is an error like 1.33. So to minimize this error, we can modify this trapezoidal rule. So that is what we call composite trapezoidal rule. So I hope to see you all again with composite trapezoidal rule. Until then, take care.